Hello and welcome to the next part of the tutorial series on how to create your first DirectX 12 application in C++ from scratch. Um, During the last episode, we did some uploading of different information. We created a material buffer that is basically a so-called diffuse albedo that gets uploaded to the GPU. And we specified it as follows: a material that reflects a primarily red light with a blue tint. And we also created a so-called lights, a directional lights, which basically just has a normalized direction vector and a strength to it. We also allowed the possibility of creating a position for the lights. Yeah, um, you can do as you see fit. We update the lights as part of a the pass data constant buffer that gets updated every frame, and we bind it to the pipeline. Actually, we haven't bound it to our pixel shader, but we will do that just now. We will do our pass data here, since it's the first root buffer, a rather constant buffer bound to the first root parameter. It will of course be in register 0. All right, now that is actually bound to our pipeline. We need to do some stuff in terms of our shader programs here. We want our vertex shader here. It takes in a normal, it takes in a position, it outputs a screen space position, but it doesn't output the normal. And we would like for it to pass along the normal here, which is the per vertex normal that will be interpolated between each pixel. Remember, the pixel shader and the rasterizer interpolates between pixels for you. So this handles everything per vertex, but it outputs something that the rasterization unit can use to actually draw pixels, and the pixel shader can use for interpolation. We use our pass data here. We output our vertex shader output here. We want to change our pixel shader input to something like that. And right now everything should work fine. We have no problem. All right. So right now we pass along our vertex information. We also have a light data structure. I would like to see if we actually have any information on the GPU in terms of the light data. So I'll, whoops. Okay. I probably have to move some shaders here. I haven't updated the shaders for the NVIDIA Insight part of the thing, so I'll just show you in our application here. We need the shaders, and we need to post them in here where NVIDIA uses the application. Yeah, it runs fine outside NVIDIA Insight, so let's try again. Now it runs fine. Okay, let's see if we can find our pass data buffer. We actually haven't named it. That annoys me a bit. This is an upload heap buffer, so it could be 255, 56 bytes. That could be our buffer here. Let's see. It would contain a view projection matrix, and then it would contain our float 3, float 3, float light data, right? Let's see. Let's see. Wait a minute. There's an error in our code. There's an error in our code. We do not want to offset by the whole. We don't want to offset the whole size of the pass data. We only want to offset the part with the view projection matrix, because we want the lights, of course, to be first we only want to write the view projection matrix, and then we only want to offset by the view projection matrix. So now everything should be properly aligned in our video memory here. Let's see. What have you got for us? Oh, that's the description. All right, everything already looks better. As you can see, we have some information there. Let's see, float, float 3, float. Okay, so our first position is 0, that's fine. Our strength is 1, I think. Let's see. Does that correspond to what we actually specified in here? The position is the first field, then the strength. So this should actually be ordered like this. And we could simply show the position here, although it's 0 and not needed. We can just do this so we can see the outline of the actual struct in memory. Okay, so that actually is correct now. Great stuff. So that was a small bug. Be mindful of your mem copies. It's easy to miss the target by a small to a large amount of bytes. Anyway, so our data is actually uploaded. That's pretty great. We will do some, try to do some shading here. Excuse me. We will try to specify an intensity of our light here. And we want to create a color. That will be, no. And we want to specify the intensity by taking the dot product of our pass data, not material data, pass data, light dot direction here. I can't see anything there. And we want to take our input normal here. We can't see anything. And by doing the dot product, we find how much these two vectors align. If they are completely aligned, we will have a high intensity. If not, we will have a lower intensity. So let's just do something like this for testing. Then we will set the color to something, let's see, a float for with the color of red, a bit of green here, and a bit of blue, and of course an alpha of 1. Else if the intensity is larger than 0.5, we maybe tune down the color here. And we can do 25 here and do 6, 1, and else we will set the color as this. Um, this is not really nice shader code, but hopefully it won't be too slow. And let's try that. Let's see. Okay, we can't open them. Whoops. Hmm. And then we perhaps want to multiply that by our diffuse albedo. Well, that didn't really do anything, did it? Let's see. Let's try to normalize this. And let's see. Okay, maybe we need to. Oh yeah, okay. I know why. I know why. In our vertex shader, we're not really transforming our normals here. We need to transform them. So let's do that. I think at least we need to do that. And then we will take the RGB. Wait a minute. Okay, there we go, RGB. Well, that doesn't change anything. Let me see in debug mode. All right, do we actually upload our normal data? Let's try looking at that. Okay, this has a different shading, of course, but let's see our vertex buffer here. Flow 3, flow 3. And let's do indices. Huh. Maybe I need to translate the normal in a different way. Let me see. What do I usually do in terms of that? Shader programming is not my strong suit, but I think we will figure it out. Normal world. Usually I would do like this. No, maybe I would. Maybe I would actually not do that. No, I wouldn't do this. That doesn't make any sense. Because the normal is in world space coordinates. Does this actually only work or what? Nope. Let's do the color for now. Maybe we need to. Let's try rotating the camera. Yep. That doesn't change anything. Oh, okay. I'm playing around with a so-called Toon Shader and the lighting. Oh, there we go. So the vector was not pointing in the right direction. So my stuff was actually correct. We now have a toon shaded square. It's not much, but it is something. And now we get the 3D perspective of things. Let's see. Maybe the material is a bit dim. No, maybe we want to tune it down instead. All right. All right, great stuff. Maybe this needs to be a bit dimmer because maybe the difference isn't that big when the lighting doesn't apply properly. Maybe you actually want to reset these and let the material drive the actual color of these. So let's just do these as scaling factors, and instead let the material decide how light or dark the thing is. So now we can control the material itself. A bit more here. Let's do 25 here. Okay. That's actually pretty decent. Okay. So now we have written a shader program that I have explained exactly nothing about. So let me quickly do that. We had our information bound to our pipeline readily available. There we go. So what we generally do is that we pass along our normal coordinates for each vertex into our pixel shader, which means that the normal position for each pixel is interpolated between the vertices that we're rendering, or if we're rendering some piece between two different vertices. We have uploaded some lighting data, just a directional light, which we also bind to our pixel shader here. Inside our pixel shader, we check if the direction of the directional light and the normal of the pixel are pointing in the same direction. If they are pointing in the same direction, it means that yeah, actually we could negate one of these, because right now can we do that? Maybe we can do minus. Yeah, we can actually do minus because I want to change this so that it actually points downwards. Anyway, so if the opposite direction of our um, global directional light has the same direction as our pixel normal, that means that the light is probably shining directly on that pixel, and it will have a high intensity in terms of coloring. If it's in the opposite direction, we're probably not shining any light on that particular pixel, and therefore it gets darker. We simply specify a parameter here that is a factor that controls how intense the color is, and we multiply that by the material diffuse albedo, which is the base color that the object material actually reflects whenever it's lit. And that gives us this kind of perspective here. Let's try moving the camera a bit. Let's see, maybe we want to move even further out here and maybe a bit higher up. As you can see, everything has a nice 3D perspective in terms of some sides of this cube are more lit than others. So that's basically a Toon/Cell shader. You simply do simple lighting models, and yeah, if we had a more complex figure, you would be able to see more interesting lights. Yeah, you could implement a model loader and actually see how the lights would turn out. Maybe I'll do an example where we use our model loader and actually load some interesting models here. But for now, we won't do that. We will instead do one last important topic, and that is transforms. And we will use transforms to manipulate our object. Since transforms handles on a vertex basis rotation, scaling, and translation slash also called movement. So we will do that in the last episode, and maybe we will animate something a bit. Yeah, so that's basically it. Yeah. Maybe we will also do multiple objects of the same mesh, but with different attributes, since this actually allows us to do something like this. Okay, and I swear it will probably be the last episode. All right, any questions before we round this episode off? If you really wanted to see shadows, should we do it? Let me just check you, my friend. Can I react? Oh, it's hidden behind this or what? Oh, I hate the YouTube interface here. Let's see. Let's see. Well, can I do? Huh, that's weird. I can't choose reply. Okay, but anyway, I'll consider doing shadows. That's it for this episode. If you found it helpful, inspirational, entertaining, or something else, feel free to comment, like, or subscribe, or support the channel. Hopefully, I'll be seeing you in the next episode.